let's look at some information that we can gain from the periodic table. First, we'll go over group names. This first column on the left is called the alkali metals. Notice that hydrogen is not part of it. The second group is called the alkaline earth metals. This grayed section in the middle is called the transition metals. The section below it that's also in gray are called the intertransition metals. They belong in the periodic table as well, but they're put at the bottom to save space. This group on the right is called the halogens. They are very reactive. And the group on the far right are called the noble gases or inert gases because they are not reactive at all. This step you see is what separates the metals from the nonmetals. Technically, hydrogen is a nonmetal and should go over to the right, but because of its properties, it stays on the left. These circled elements are called metalloids, and they have properties of both metals and nonmetals. So what do columns in the periodic table have in common? Columns are called groups or families because they all have similar properties. They also have the same number of valence electrons, which means they're going to create the same charge when they become ions. So let's look at a couple of examples of these. Group 1 here has one valence electron. So if we look at the sodium ion and its one valence electron at the top, it's going to be easier to get rid of that 1 than it is going to be to take on 7, so it ends up having a positive 1 charge. So everything in this first column creates a plus 1 charge. If we look at everything in the second column, it has 2 valence electrons like we've already talked about, so this magnesium atom is going to get rid of the valence electrons rather than try to take on 6 more, so it's going to have an overall positive 2 charge, and everything in column 2 is going to have a positive 2 charge. If we go to the other side of the periodic table and look at the group with oxygen, everything has 6 valence electrons, and it's going to be easier to take on 2 than it is to get rid of 6. So it's going to have 2 more electrons, and it's going to have an overall negative 2 charge. So on the periodic table, the number of valence electrons is on the top, and the charge is on the bottom. So as we've talked about, we have 1 through 8, and we skip the transition metals. And then the charges on the bottom correspond to those valence electrons. Let's talk about the rows. Rows go left to right. All elements in a row of the periodic table have the same number of energy levels, and each energy level can only hold a certain number of electrons, as you see in this table. So let's look at some examples of these. The number of valence electrons stays the same, but the energy level increases by 1 every time you go down a row. It's the same on the left as it is on the right. The number of valence electrons stays the same, but the energy level increases. So if you look at this abbreviated periodic table, you can see as you go left to right in a single row, you're only gaining 1 valence electron. And as you go top to bottom, you're gaining 1 energy level. Those electrons in that column stay the same.
Created using Powtoon.